Mm. And I have a class at 4 o'clock today. So at PST time, right? So I'm going to put an alarm because I totally forget when I start teaching that
Uh-huh.
I have to take another class. So I'll set an alarm of um, 3:57. Okay, yes. All right. Uh, Menha's class, 9th October. Or should I start a new new document? Yes, because all right. So we are going to study about the electron transfer reaction. Yeah,
Yeah.
electron transfer reactions. However, Minna, I wanted to ask you that whatever we have studied till now, all the chapters we have done, I hope they all are clear to you, yeah?
Yeah.
Any confusion?
Nope.
All right, good. Electron transfer reactions. Let me start off with the topic that says electron transfer. Now, when electron is transferred, there are two possibilities. The first possibility is that the electron is gained in the transfer, or electron
Um,
is, yeah,
are you sharing the screen?
I'm not sure. Yeah, I have. Let me let me check again. Yeah, I have shared the screen. I'll start again. Can you see now?
Yeah.
All right, okay. Electron transfer reactions, yeah? When we talk about electron transfer reactions, there are two ways in which the electron can be transferred. Either it is gained or it is lost, yeah? So
Yeah.
when an electron is gained, that is called as a reduction. And when an electron is lost, that is called as oxidation. Yeah. So that's the
Yeah.
main word. That is the technical, basically, oxidation is a technical word for the electron loss, and reduction is a technical word for electron gain. Yeah.
Yeah.
Now, in most of the reaction, almost uh, 90% of the reaction, there is always a transfer of electron, sometimes from one element to another element, right? For example, in ionic bond, the electron transfer takes place, right? So we get a cation and we get an anion, right? So cation is something, oh, let me write it the opposite way, otherwise it would be. So when the electron is gained and in an ionic bond, an anion is formed and a cation is formed. Yeah, and
Yeah.
this is something which happens in the very basic bond that is called as an ionic bond. However, covalent bond is actually about the sharing of the electron, and as in case of electron loss or gain, there is a change in the oxidation number. So we are going to stick only to the first type of chemical reaction, that is ionic bonding. Yeah.
Yeah.
So as far as anion and cation is concerned, if we elaborate on it, anion is always formed by a non-metal most of the time, and
Yeah.
cation is formed by a metal, because a metal can lose electron and a non-metal can gain electron. So the basic word which comes from this discussion is the oxidation and reduction.
Yeah.
Oxidation and reduction. Now, as far as oxidation and reduction is concerned, as I told you earlier, that there are three, four definitions which we need to follow for oxidation and reduction, and which help us a lot in understanding oxidation and reduction. Now, these are: number one, the very first definition which we have done, that oxidation is the loss of electron. All right,
Yep.
loss of electron. Now keep this thing in mind, that the opposite of oxidation is reduction. The opposite of oxidation is reduction. So whatever I'm going to write in this column, in this column, I will write exactly the opposite of that thing in the other column, that is for the reduction. Yeah.
Yeah.
So starting off, oxidation is loss of electron. That means reduction is gain of electron.
Yeah.
Number two is when an electron is lost, there is always an increase in oxidation state or oxidation number. I'll show you how. And in reduction, what is the opposite of increase in oxidation number? That would be a decrease in oxidation number. All right,
Yeah.
decrease in oxidation number. Now, the third definition is connected to it, that oxidation is the addition of oxygen, and uh, uh, for reduction, as we are going to write the opposite of everything. So what are the main words? I'll highlight them. Loss, increase, addition. So what is the opposite of addition? Removal. So the
Yeah.
removal of oxygen is called as the reduction. The last definition is removal of hydrogen, and the opposite of removal, that would be the gain in hydrogen. So that would be number four, gain of hydrogen or gain in hydrogen, right? So these are the four definitions. Now, as far as these three definitions are concerned, the first two definitions, they are interdependent. What do I mean by interdependent? Interdependent means that if one is going to occur, the other will definitely take place. That means if a metal is going to lose the electrons, that means, in other way, that means increase in oxidation number. How is this so? Let me give you an example in which both of these things would work, right? I'm making a pair here and here. So I'm talking about the first two definitions and the first two definitions of reduction. All right. So in your book, and if both the things would take place simultaneously, that is called as a redox reaction. Yeah. So I'm going to write an equation in which you can see that both the things would take place simultaneously, and that is called as redox reaction. The first one is, let's suppose if I write 2 mg, which is a metal, plus O2, that makes up 2 mgO, metal oxide. So this is metal, this is oxygen, and this is metal oxide. Now, if we look closely at it, anything which is present in the periodic table has an oxidation number of 0. Got it? You know that it's an ionic bond because whenever a bond is formed between a metal and a non-metal, or in other words, I remember I have already taught you this. This has been taken from second group and this has been taken from sixth group. So whenever a bond is formed between 1 and 7th group, 2 and 7th group, 2 and 6th group, or 1 and 7th group, 1 and 6th group, the bonds would be always ionic. Are you getting my point, right?
Yep.
So that means that the bond would be ionic. If the bond is going to be ionic, that means that one element will gain an electron and the other element will lose an electron. And we know that the element which is going to lose the electron would be metal, and the element which is going to gain the electron would be non-metal. So if we dissect this reaction, we will come to know that Mg changes from, it loses the electron by doing this. Mg positive 2 plus 2 electron. By the way, it's solid, it's gas, and it's solid, right? So now what has happened? Magnesium has lost 2 electrons. Now have a look here. What is the original oxidation number on magnesium? 0. So from 0, it has been changed to plus 2. So what is it? It is actually the increase in oxidation number, right? So whenever an electron is lost, there will always be an increase in oxidation number. Is it clear, Minha?
Yeah.
So as the electrons have been lost, so that means the oxidation number has been changed from 0 to +2. So we can say that it is the increase in oxidation number. And now the other element, what is the other element? I am not making the direct equation. I am making the equation in two steps. So I am going to write oxidation in front of this. And then the other equation, that is O2, I'll take O2 and gas, solid, that is gas, and that is, these are the electrons. Now always keep this thing in mind, that the two electrons which have been lost by magnesium, oxygen will gain them. This is the ionic bond, yeah, and this is between 2 and 6. All right, so two electrons will be lost by magnesium and two electrons will be gained by oxygen, because 6 plus 2 is 8. So two electrons to complete the octet, so that changes into O minus 2 gaseous. All right, so this is it. Now add them up. And what is this? This is reduction. And I have told you multiple times that if the electrons are written after the arrow like this, it is the loss of electron. And if the arrow is written, oh, sorry, electrons are written before the arrow, this is called as the gain of electron, right? Now add these
Yep.
two equations up. Two electron would be cancelled by two electron, and then we are going to copy the other thing. That would be now Mg solid plus O2 gas. I have copied all the reactants. These two reactants are left. After writing the reactants, I'm going to write the products. So I'll write the products now, arrow, and the products would be Mg positive 2 gas plus O negative 2 gas. So this would be the overall equation. And this is an ionic compound which is forming a crystal lattice. So I am going to write it like that. So it becomes Mg solid plus O2 gas changes into MgO, because positive 2 charge would be cancelled by a negative 2 charge, and then we have to mingle them up and it becomes MgO solid. Now please check that this equation exactly matches with this equation. Yeah, so this is the
Yep.
way of constructing this equation. So if you have a look, you will come to know that the first two equations, as the first two definitions have been satisfied: loss of electron and increase in oxidation. So does it make sense, Bache?
Yep.
Good. There is another example given in your book, that is called as Mg solid plus Cl2 gas forming MgCl2 solid. This follows the same rule, because if you check this is an ionic compound. Why? Because it has been made between metal and non-metal. So if you are going to dissect MgCl2, you know how did you make this? Because Mg has a charge +2 and Cl has a charge -1. So cross multiply and you are going to get MgCl2. Are you getting my point?
Yep.
So that means that there must be a charge of +2 on magnesium and a -1 charge on chloride ion. So how magnesium is going to get a +2 charge? Because here it is 0. So if it loses 2 electrons, it is going to get a charge of +2. So Mg solid, arrow, Mg plus 2 electrons. Are you getting my point now? The,
Yep.
the ionic bond has been formed between 2 and 7. First, it was 2 and 6. You know that, right? Because magnesium is from second group beta, second group, and chlorine is from seventh group. So that is between metal and non-metal. That is between second group and seventh group. Just a minute, Minha.
Yep.
वो फोन कर लेना था, मुझे फोन आया था, अभी करके जाओ. Okay, sorry for the disturbance, Minna.
Okay.
All right. Magnesium
Um,
solid change. Yes.
just a little bit above. You know how you wrote the ionic bond between the groups?
Yeah, here. Yes. Yes.
Yeah. Is that 2 and 7. How is that possible?
Two and is it is possible. Well, how come?
Isn't the
What is
octet 8?
no, sweetheart? Have a look. Two is what, magnesium,
Yep,
and seven is what, chlorine.
yep.
We are doing the same.
Oh, okay, okay.
All right. So it is possible, bache. Have a look. Magnesium is going to lose two electrons,
Yep,
and chlorine will take only one electron.
yep.
So if two chlorine atoms would come, then
Oh, okay, okay.
correct. Okay.
Yep,
So now I'm giving you the example for the same thing, beta.
yep,
All right.
yep,
Okay. Now, magnesium is going to lose because it is in group two. So there is no need to memorize it. You know what, Minha? The periodic table is always given to you in the paper, right? So if you look at the periodic table and if something is in group two, that means it is going to lose two electrons. Yeah,
yep,
and if something is in group one, that means it is going to lose one electron, no matter it's lithium, sodium, potassium, rubidium, or cesium, or even or francium, right? And
yep.
when you move on towards the right side of the periodic table, that is sixth group, seventh group, you know that this is non-metal. This is something which you need to remember. That's it. That
Yep,
group fifth, sixth, and seventh, they are meant for non-metals. Now, no, you know that non-metals, they gain electron. Now, if
yep.
something is in group number six, that means how many electrons in the valence shell? Six electrons. So
6.
how many? Now there are two options, but say if something is in group six, beta, there are two options. Either it will lose six electrons or it will gain two electrons. Which thing is easier?
Gain 2 electrons.
If you want to lose, yes, because beta, if you want to lose six electrons, there must be some species who would be willing to take up six electrons. Nobody will
Yep,
take six electrons. One is manageable, two is manageable, sometimes three is manageable. That's it, full stop. Not more than that. Got
yep.
it? So the I hope you are getting it, Minha.
Yeah, yep,
All right. So it means when something is in six group, there are two options: either lose six electron or gain two electron. Losing six electrons would be the Herculean task because nobody is going to accept six electrons. However, somebody could be willing to give two electrons to oxygen, all right, or sulfur, or selenium, or tellurium, or polonium. Yeah. So it will gain two electrons, and if they are going to gain two electrons, beta, they will be called as non-metal because only non-metals they gain the electron, right? Now, magnesium is going to lose two electrons. I have shown it. Now you need to look for someone who will be willing to accept those two electrons. Now, if you have put a hot magnesium piece in a jar which contains chlorine atoms or chlorine gas, now there is no other option other than to make the compound. Are you getting my point, right?
yep,
Because you force them to react. You forced them to react. So what is going to happen? Magnesium will say, I am going to give two electrons. Chlorine would say, but I can accept only one electron because I have got seven electrons in my valence shell. Then oxygen will give an idea. Okay, then fine, bring two atoms. One would be taken up by each atom, and then I can give my two electrons, and two chlorine would accept one electron each, and we will make a compound magnesium chloride. So this is called as negotiation. This is called as mutual agreement, right? So
yep,
this is as the electrons are lost, beta. So this is called as what? This is called as oxidation, and then now this is very important. I will bring two chlorine atoms and then two electrons, and it will change into 2Cl negative. Are you getting my point, right?
yep.
And oh, sorry. Just a minute. I'll write it like this. It would be easy for you to understand. Cl2, right? Okay,
Yeah,
okay. Cl2, because chlorine is a gas, it's a diatomic gas. Now, this is reduction because the electrons have been gained, the same electrons which have been lost by magnesium, and better we are going to get this. All right. So, what is it? That Mg solid, now write the reactants. Mg solid plus Cl2 gas changes into Mg positive 2 gas plus 2Cl negative gas. Now, because you know that these are the ions, and you can easily cut or cancel the charges. So this two, I told you how this two goes in the subscript, right? So it becomes
Yep.
Mg plus Cl2 solid gas. It changes into MgCl2 solid. When the gaseous ions, they form they form a crystal lattice, and you know that when a bond is formed, that is an exothermic reaction, right? So when magnesium ion comes close to chloride ions, two chloride ions, now we are going to get a crystal lattice, and when they are going to combine, they are going to form a bond. Energy would be released because forming the bonds is an exothermic reaction, and then we are going to get a crystal lattice at a very low energy level, which is very stable. I hope it's clear.
Yep.
So both the definitions have been done. However, now comes the next one. That is what? That is addition of oxygen. Now, I think addition of oxygen has already been covered in this, because you can see, Bete, that oxygen has been added.
Yep.
All right. So this definition is also covered. That is addition of oxygen. All right. I hope it's all clear.
Yep.
Now the last one, loss of electrons. Now, the loss, the last definition is loss of hydrogen. Yes. Now I'm going to cover that loss or removal of hydrogen. So that would be like if we have H2S, hydrogen sulfide, right? Plus oxygen. Now, this is aqueous and this is gas. It forms H2SO4. Counterbalance it, that would become 2. Yes. So now it is balanced. Have a look now. What it is? What is it? Hydrogen sulfide. Now hydrogen sulfide has been changed to sulfuric acid. All right.
Yep.
So you can say that actually what has happened when we in this equation, and let me write the other one as well. H2S plus O2, another equation on at different temperature, right? So this would be like H2O plus S. Let me counterbalance this. This is 2. So 2. Okay. That would be 2 and then 2. That's it. All right. So this is aqueous, gas, so liquid, and solid. So that is it. Now, if you have a look, this equation gives you a clear idea. Now, if you look at hydrogen sulfide, when you go to the product, hydrogen sulfide has changed into water. So what has been changed? S. All
Yep.
right. And or you can say that hydrogen has combined with H2, and then S has been given out. So what has happened actually? That sulfur has lost hydrogen. Can you see that?
Yep.
Sulfur, sulfur has lost hydrogen. So what is it? A reduction. And
Okay.
hydrogen has gained oxygen. Hydrogen has gained oxygen. So this is somewhat oxidation. Is it clear?
Yep.
All right. But if you check now, what about the above equation? Now, if we check the above equation, H2S changes into H2SO4. Now, if we look at the oxidation number, you must have seen the second definition, that is increase in oxidation number, right? So if we check the oxidation number of sulfur, we would come to know whether something has happened to sulfur or not. What something has oxidation or reduction. So let's check it out. Are you getting my point? And you know about, yes, Minha?
A little bit. Yeah.
A little bit. All right. Okay, fine. So let's check the, we want, I'm talking about the above equation, this one.
Yeah.
H2SO4 plus O2. Let me
Yep.
write the whole equation. H2SO4. Now let's check sulfur only. If there
Yep.
would be any change in sulfur, then we will be confirmed that oxidation or reduction has taken place. So find out the oxidation number of sulfur. You know that the overall oxidation number is always 0.
Yep.
हाँ थोड़ी सी है वो लेटर में वो जहाँ पर बाकी चीजें रखी होती है। आई एम सॉरी मैन हाइट में वो
No
छोटे
worries.
छोटे वो नहीं होते ओरिगैनो के होते हैं शीशे की बोतल लंबी, उसके साथ एक और नहीं है, फिर नहीं टाइम होगी वो। All right. H2S. So the overall oxidation number is zero, right? You know
Yep.
that hydrogen is always plus one. You know
Yep.
that. Apart from hydride, I will write the rules afterward. Apart from hydride, where metal hydride, where it is minus one. Otherwise, hydrogen is always plus one. I'll tell you
Yep.
how in metal hydride it's minus one. So, betray this is 2 plus 1 plus x. I want to find out for sulfur. X is equal to 0. So
Yep.
plus 2 plus x is equal to 0 and x is equal to minus 2. Is it clear?
Yep.
Now H2SO4. Again, the overall would be 0, right?
Yep.
So that would be 2 plus 1 plus x plus what is O? Minus 2. You know about that,
Yep.
right? 4 times minus 2 is equal to 0. Solve it. Plus 2 plus x minus 8 is equal to 0. Minus 8 and plus 2 would be x minus 6 is equal to 0. And x is equal to plus 6. Are you getting my point?
Yep.
All right. So now from x minus 2, we have gone from where? A minus 2 minus 1 0 plus 1 plus 2 plus 3 plus 4 plus 5 and plus 6. So what is it? Have a look. Increase in oxidation number. Am I right?
Yep.
So what is it? Oxidation.
Okay.
There you are. Increase in oxidation number. Are you getting my
Yep.
point? Yeah. So you
Yes.
know what? When you go from minus to plus, it means the number is increasing according to the maths rule.
Yep.
So many times? One fold, two fold, three, four fold. All right. One fold, two fold, three, four fold, five fold, six fold, seven fold. All right.
Yep.
All right. So this is what, beta, this is oxidation. Let me complete this. This is oxidation. I hope it's clear.
Couldn't you also said that it's oxidation because it's a gain of oxygen?
This one, for this one.
Yeah.
All right. This is actually, you know what? This is difficult to understand in terms of oxidation because what I can say is H2S doesn't have any oxygen here. Can you
Yeah.
see that? And then what has happened in the product?
It has an oxygen.
Yeah. So what is it actually?
Oxidation.
Yeah. Are you getting my point?
Yeah.
But it is somewhat a little bit difficult to understand. But I have told you in that way as well. But I will tell you in both the ways. Have a look here. This is H2. If you see that in H2S, there is no oxygen. But in the
Yep.
product, oxygen is there. So what we can say? Addition of oxygen.
Yep.
So that is oxidation.
Okay. Okay.
All right. And
And
other,
then
and yeah.
and then what about in like the bottom equation, the H2S?
So I'll tell you about that. I have related this to this thing, right? The
Yep.
first equation. Now comes the second equation. The second equation beta says that H2S has sulfur in it, right? H2S has sulfur in it. Okay. Now see that H2S has changed into S.
Yep.
So that means, what does it mean? That hydrogen has been lost.
Yep.
So when hydrogen is lost, it is what? It is oxidation.
Yep.
So in this way, you can. So you know what? What I'm trying to tell you is that this is somewhat a pair. Whenever an electron is lost, there would always be an increase in the oxidation number. But there must be any, maybe you will come across in the paper in the exam, maybe you will come across an equation where simply oxygen is added or a hydrogen is removed. Yeah. For
Yep.
example, in this equation, can you see that hydrogen is removed from sulfur?
Yep.
So that could be called as oxidation. Yeah.
Yep. Okay.
Or in other words, let me tell you in another way. Or in other words, beta, you can also say that oxygen has been added to hydrogen.
Yep.
So it is also oxidation.
Yeah, okay.
So, all right, some equations can give only oxidation. Sometimes it means what I'm trying to tell you, it means that all the four things would not be fulfilled in one equation.
Yeah,
Maybe only one thing would be fulfilled. I was just trying to tell you that maybe there are some reactions in which the first two definitions would operate.
yeah,
But it is not a hard and fast rule that every time two definitions or all the four definitions would be there or would be seen. Maybe only one definition would apply at some time. Yeah? Okay,
yep,
good. Should we go further along now?
yes.
That's about it. And then we are coming to the next equation. That is, yeah. If you check on mm, page number, let me tell you, page number 496,
Yep,
we have done all the four definitions.
yep,
All right, and they have given the equation, the above definition in this sorry the above equation in this form as well. In the oxidation, we have already done that. I have done that for H2S, and they are doing it for this one as well. H2S plus O2 changes into S plus H2O. One and the same thing, right? Hydrogen is plus one, all right, and
yep.
sulfur is if you will, if hydrogen is not plus one, let me write it, it's plus two. Why? Let me tell you, because
There's
hydrogen
two
is,
hydrogen.
yeah, oh dear, so there are two hydrogens plus one, and then S is equal to zero, so that means plus two plus S is equal to zero, and S would be minus two. So if I will write bit plus two and minus two, yes or no?
Yep,
Yeah, and then oxygen is always zero. Yeah,
yep,
and then sulfur is always zero, and then water is plus two and O is minus two. Are you getting my point?
yep,
So please check that hydrogen H2 is plus two, sulfur is minus two, are you following it? Oxygen is
yep,
zero, sulfur is zero, hydrogen is plus two, and oxygen is minus two. Now please check. Plus two hydrogen and plus two hydrogen, there is no change in hydrogen.
yep,
Yes. Now, sulfur minus 2 and sulfur 0. That is decrease.
yep,
That is like this minus 2, minus 1, and 0. So, what is it? Increase in oxidation number.
yep,
All right. Now, come to oxygen. Oxygen is 0 here, and then it is minus 2. So, what is it? 0, minus 1, minus 2 going down. Decrease in oxidation number.
yep,
Are you getting my point, Minha? It's a bit
yes,
confusing, but it makes a clear sense, right?
yep,
So sulfur from minus 2 beta, it is changing to 0. So that is increase in oxidation number because we are going from minus 2 to plus 0.
yep,
So increase in oxidation number. So this is oxidation. And then beta, I'll use another color. Then for oxygen, we had 0 and then it changed to minus 2. So we are going down. That is decrease in oxidation number. So if it is a decrease in oxidation number, it's reduction.
yep,
So what we can say, bache, that sulfur is being what? Oxidized,
yep,
and oxygen is being reduced. As simple as that.
yep,
Now, I think we have done a lot of examples. So it should be
yes,
clear, right? Yeah, we have done one, two, three, four, and five. Five examples in all different ways, right? But always keep this thing in your mind. Don't think that all the four definitions would apply.
yep.
Okay, now the oxidation number. Calculating second topic. Yeah, it's all clear. Should I go further along?
Yes, yes, yes.
So we have, let me confirm it from your book, Bata. That is, so we have started from page 4, 93, 1, 2, 3, 4. We are on page number 496.
Yep.
All right. Okay, now coming to the next topic. What is it? Oxidation state number redox reaction. Okay, the other topic is calculating oxidation number. Do you have the idea of this concept? Or if not,
Yep.
then we can go further along. Yes, tell me. Should we do it, for
Yep.
example, if I write Cu NH362 positive. So if they ask you to calculate the oxidation number of the different elements present in it. So can you do it, or should we skip it? Should we do it, or should we skip it?
I know how to do it, but can we do this example?
Oh, sure, sure, sure. Now, the very first thing, beta, this is for metal, this is the oxidation number.
Yep.
Clear? So the very first thing, copper has the oxidation number +2. So Cu is equal to +2. On the
Yep.
other hand, what is left? Ammonia. All right?
Yep.
So ammonia is a ligand and it has an overall the oxidation number is 0.
Yep.
All right. So what we can do is they simply ask this. They simply ask assign oxidation state to the metal ion. Yeah.
Yep.
So, but let's calculate for N and H3 as well. Yeah. So NH3 is equal to 0. First calculate for N. So that would be beta, that would be X plus 3 times plus 1 is equal to 0. X plus 3 is equal to 0. X is equal to -3. All right,
Yep.
so that means that nitrogen is -3, and there is no need to calculate for hydrogen. You know that hydrogen is +1. So 3 times plus 1 would be +3. So -3 would be cancelled by +3, and that is why ammonia is 0.
Yep.
Is it clear? And then they
Yes.
gave another one that is an ammonia tetraamino dichloro chromium positive 1 cation. Again, the same thing, but oh, sorry. Same thing that chromium has the oxidation number, which is the overall charge. Okay?
Yep. For the
Hmm.
previous one, would you not times it by six? Like, isn't there nine? Sorry, six nitrogens?
Here, no, there is no need, Pijay. Actually, this is one separate molecule. So if you have six separate molecules, you need to calculate only for one. They are
Okay,
they
okay,
are
okay.
different. Yeah, they have different
Yep.
species. Yeah. So every we need to calculate it for ammonia. All right. No
Yep.
matter how many ammonias are there, you can
Yep.
do that. You can also do that, but it will only make the things difficult. That's about it. Nothing more. All right.
Yep.
All right. So now the next one is use oxidation state to deduce which species oxidize and which species reduce. We calculated the oxidation number for the formulae,
Yep.
right? We did it for formulae. Now we can do it for equation. Are you getting my point?
Yes.
Calculating oxidation number, number one for formulae, number two for equations. So this is formulae and this is equation. So we did for formula. Now we are going to do the equation. I'll pick up the the most difficult one, right?
Yep.
So that would be 2MnO4 negative aqueous plus 6H positive aqueous plus 5SO3 negative 2 aqueous arrow 2Mn2 positive aqueous plus 3H2O liquid plus 5SO4 2 minus aqueous. Yeah. All right. You know what,
Yep.
Minha? In our syllabus, we used to derive these equations.
Oh.
Yeah, we derive these equations. Anyway, let's start it off. Now it is saying to deduce which species is oxidized and which species is reduced. All right. Now, what when we were doing it, but we used to do it for a specific species which are highlighted by the examiner. But as nothing has been highlighted, so we are going to calculate it for each and every species. Are you getting my point?
Yep.
So first of all, MnO4 negative, right? Now I will not calculate it for 2 MnO4. I will simply calculate it for Mn, right? So
Yep.
here it is. I'll do it one by one. MnO4 O4 is negative, right? Now what does it mean? Now it's a bit tricky. Have a look, but Chase, what does it mean? It means that MnO4 negative is equal to -1. Are you getting my?
Yep.
So now we need to, I'll highlight which I am calculating Mn. So that would be x plus 4 minus 2. You know that oxygen is -2, right? Is equal to -1. Yes.
Yep.
-8 is equal to -1. X is equal to -1 plus 8. X is equal to +7. So we got the oxidation number for, I'm sorry, just let me take an inhaler.
Yep.
Yes. So we have all right, we have +7. So I am going to write +7 here. Okay. So we have
Yep.
found this. Then comes the second one. Let me highlight this one. So as I told you that what is the charge, whatever is the charge on the ion, that is the oxidation number. So we do not need to calculate it. It's already there that Mn is here is +2. Can
Yep.
you see? Can you see, bache, that Mn has been changed from +7 to +2?
Yep. So reduction.
Reduction. Well done. So you can deduce that manganese has been reduced. Okay, bache?
Yep.
All right. Now come to the next one. 6H positive. We know that hydrogen is +1.
Yep.
Hydrogen is +1. All right, now comes this thing, SO3. So we need to calculate S here and F here. Are you getting my point?
Yep.
All right. So +1, then what else? As far as O is concerned, better you know that O is -2. Yeah.
Yep.
However, there are 4 O's, but we are not going to make it -8. We will make it -2. It will keep our thing simple. Okay.
Yep.
All right. Now, hydrogen I have already calculated, that is +1. Okay. And
Okay.
now SO3. So SO3. What is the overall charge on SO3?
-2.
-2. So here it is. X plus 3 times O is -2. You know that. -2. Yes, Minha, if
Yeah. Yeah.
you
Yeah.
all right. X is equal to -2 plus 6. So X is equal to +4. So
Yep.
sulfur is +4 here. All
Yep.
right. Now we will check it here. SO4 -2. SO4 -2. SO3 -2. Now check this out. So again, that means SO4 is equal to -2. Now,
Yep.
but say X plus 4 minus 2 is equal to -2. X minus 8 is equal to -2. X is equal to -2 plus 8. X is equal to +6. So
Yep.
sulfur here is +6. That is changing from +4 to +6. So what is it? It's oxidation.
Yep.
Is it clear? So what has been
Yes.
reduced? So I'm going to write, beta, MnO4 -1 is reduced to Mn positive 2. And then I will write SO3 -2 is oxidized to SO -4 -2. SO4 -2. Clear?
Yep.
So I'm not doing the way it is given in your book. It is quite complex, so I'm doing it in this way.
Yep.
Clear? Is it all fine?
All clear.
Yeah, however, please check what is written underneath on page number 497. Please check part in the solution. Please check part C.
Yep.
And under the table, there are two sentences written. Can you please read them? MnO4 negative aqueous.
Is reduced because the oxidation state of Mn decreases from +7 to +2.
Yeah.
S.
So can just a minute. Can you see +7? I have already shown you that. +7 to +2. All right.
Yep.
And then the next line.
SO3 2 minus is oxidized because the oxidation state of S increases from +6 to +4 to +6.
Yeah, here it is. Can you see here? +6 to +4 to +6. Is it clear?
Yep.
Here it is. +4 to +6. So I think it's all clear. I tried to take the most difficult thing, so the equation, so that you can easily do it. All right.
Yep.
Now comes oxidizing it. Okay, there is another example given, very absurd example. Let me say that. Assign oxidation state to carbon in C3H8 and comment on your answer. All right. So what can you say that C3H8? Yeah, should we do this? Should we do
Yep.
this? So according to this, so according to this, we have we have S uh, C3H8. All right. So what is it? We need to assign the oxidation number. So actually, how many carbon atoms are there? One, two, three. All right. So what is it? So if you calculate hydrogens, one, two, three, four, five, six, seven, eight. All right. So they are doing it in a very weird way because there are eight hydrogens. I'll try to explain you. Eight hydrogens and three carbons.
Yep.
All right. So what they are saying that as the oxidation number assigned to hydrogen is +1. All right.
Yep.
So that would be 8 times +1 because there are 8 hydrogens, right? Plus 3C is equal to 0. All
Yep.
right. So that would be 8 plus 3C is equal to 0. And that would be 3C is equal to -8. And C is equal to -8/3. And keeping 8 inside and 3 outside, 3 to 6 -2. So that would be C is equal to -2 whole 2/3.
Yep.
So that's what they are trying to do. And this is what average, because we calculated it for one carbon.
Yep.
All right. So that's the average. I hope it's somewhat clear to you.
Yep.
All right. Okay. Now the next one is oxidizing and reducing agent. Next topic. So I hope it was clear, Minha. So I can go further along now.
Yes.
Oxidizing and reducing agents. Now, this is for if I talk about my student, that was the most difficult thing for my student until and unless I told them a trick, and that trick was with this. I'm going to rub this now with this uh, with oxidation. All right, right, reducing agent, and with reduction, right, oxidizing agent. That's it.
Yep.
So whatever is the definition for oxidation, that is the definition for reducing agent. Why? Because reducing agent does what? I think I have already explained you that when, for example, whenever we travel, the traveling agent makes our itinerary, right? But we travel, so the traveling agent doesn't travel. So what does it mean? So oxidizing agent is an agent which compels the other person to get oxidized, and itself it gets reduced.
Yep.
All right, I'm repeating again. I told you about the traveling agent that he doesn't travel himself, right? He compels the other person to travel. All right, so
Yep.
same goes for the oxidizing agent. I'm writing it here and then I'm going to relate it. Oxidizing agent, it's an agent. Agent is going to ask the other species to get oxidized, and when it will oxidize it is going to lose electrons. Am I
Lose.
right?
Yep.
Yeah. So those lost electrons will be taken up by the oxidizing agent to get reduced.
Yep.
All right. This is other species. Other species. Repeating again. Oxidizing agent asks the other species to get oxidized. And when the other species gets oxidized, it loses electron because that is oxidation, loss of electron. When that species loses electron, then those electrons are being taken up by the oxidizing agent to get reduced.
Could
What
you
is
show
bothered?
this with an example?
I am going to give you the example, but what I have told you in theory, I hope it's clear that oxide, because
Yep.
in your book it is written in a very weird way. That's why I want you to be sure that what I'm trying to tell you, then definitely, Bitta, I'm going to tell you with the example.
Yeah. Yeah.
Oxidizing agent is an agent which compels the others, it's an agent now, so it is going to compel the other species to get oxidized. When that species oxidizes, it loses electron, and then those electrons will be taken up by the oxidizing agent to get reduced, right? Now I will show
Yep.
you. Now I'll show you about the oxidizing and reducing agent. All right. So have a look. Let's suppose we have the equation Fe2O3 solid plus 3C. I keep the example same so that the level of the difficulty remains the same according to your book, right?
Yep.
So this is it. Now, simply calculate the oxidation number. Simply calculate the oxidation number Fe. FeO3, right? So write Fe 2O3 is equal to 0. All right. So that would be 2x plus 3 minus 2 is equal to 0. I'm calculating it for Fe. All right.
Yep.
So that is 2x minus 6 is equal to 0. 2x is equal to plus 6. X is equal to plus 6 over 2. X is equal to plus 3. Yes or no?
Yep.
All right. Now Fe changes to Fe2O3 changes to Fe. All right.
Yep.
So the very first thing, beta, is oxidation. Oxygen is lost.
Yep.
All right. Now check. It changes to Fe, which is 0. Fe is
Yep.
equal to 0. So from plus 3, it is changing to 0. What does it mean? It means from plus 3, plus 2, plus 1, and 0. So what is it? It's an increase in oxidation number or decrease in oxidation number?
Decrease.
Decrease. And what is decrease? It is reduction.
Reduction.
And oxidizing agent does what? It gets reduced.
Reduce.
Let me show you the definition. Gain of electron or decrease in oxidation number. So when it
Yep.
is decrease in oxidation number, it is reduced. And what is
Yep.
being reduced? Oxidizing agent.
Yep.
What is bothering you, Minha? Tell me, I will explain.
So Fe2O3 would be the
Oxidizing agent.
oxidizing agent. Yep.
Yes, good.
Okay.
So I will write that it is an oxidizing agent. Oxidizing agent. All right. Now, what is the other thing left? See, if one is oxidizing agent, beta, the other thing should be reducing agent.
Yep.
Said, let's see. So what is it? 3C. So that would be 0.
Yep.
And then it changes into CO2. Let's check. CO2. For carbon, we need to check it for carbon. X plus 2 minus 2 is equal to 0 because there is no
Yep.
charge on it, right? So X minus 4 is equal to 0 and X is equal to plus 4. So
Yep.
0 changes to plus 4. So that means 0 plus 1 plus 2 plus 3 plus 4. Or sorry, I will write it the other way around. So beta, this is 0 plus 1 plus 2 plus 3 plus 4. What is it? Increase in oxidation number or decrease?
Increase.
Increase. So when there is an increase in oxidation number, when there is an increase in oxidation number, what is it?
Oxidation, and then it would be a reducing agent.
Here it is. Look at the screen. When there is an increase in oxidation number, this would be what? Reducing agent.
Yep.
Yes or no? One thing. Yes, are you getting it?
Yep.
And the second thing, carbon is carbon is adding oxygen in it. Can you see that?
Yep.
So when carbon changes to, in the equation, can you see that carbon, oh, I'll use it. Carbon changes to carbon dioxide, right? So better carbon changes to carbon dioxide. What is happening to carbon? Adding oxygen.
Yep.
Adding oxygen means reducing agent.
Yep.
Because if you will remember this, bache, if you are going to remember this, that slash oxidation slash reducing agent, reduction slash oxidizing agent, this
Yep.
will create no problem for you. So that means if something is increasing in oxidation number, that is a reducing agent. If something is having decrease in oxidation number, that is oxidizing agent.
Yep.
All right. So we can also give this example with, for example, I will write oxidizing agent. Agent. This is the most important word. If it's an agent, it will never get oxidized, it will get reduced.
Yep.
And if it's an agent, it will ask the other species to get oxidized.
Yep.
Got my point?
Yes.
And then I will write for reducing agent. So if it's a reducing agent, it will never reduce, it will get oxidized.
Yep.
And if it's an agent, it will ask the other species to get
Reduce.
reduced. I hope it makes a clear sense now.
Yes.
All right, Bitte. So
Yep.
this is it, and but I don't know in which way they give you in the book, but I'm doing it in my own way, right?
Yep.
So the end result is the same, but definitely it is the way I am telling you is different from the way it is given in your book. But when the end result is the same, it's better to opt for the easy option.
Yep.
All right. So now I'll give you one small question for the homework. That is K2Cr2O7 plus iron 2 chloride changes into Fe3 positive and Cr3 positive. So you need to calculate the oxidation, reduction, oxidizing agent, and reducing agent, right? Don't check it from your book. All right.
Does that say CW?
Cr.
Oh, okay.
This is Cr.
And then, okay, so where does the oxygen go?
Where does the oxidation? Then I need to write the whole equation, beta. I simply want you to have a look how this has been done. How the
Okay.
otherwise you can. It is going to be changed into something tricky. I don't want to tell you right now. I simply want you to keep it simple and know which has been reduced and which has been oxidized.
Yep. Yep.
All right.
Okay.
In the next lecture, I will explain you this. Okay.
Yep.
Beta, it's yeah.
Yeah. Yep.
Yes, Minna.
Well, I was gonna say, class tomorrow, right?
All right. Okay. Okay. Exact time, right? 4 o'clock.
Yep.
Okay.
And I won't be able to have class on Monday.
Sure. Okay. No problem. However, I will update you about the time because I think I have another class at 4 o'clock tomorrow, but I'll update you. No, I think
No worries.
I have shifted it to, I think, 6 o'clock. I'll confirm you, right?
No worries. Yep.
Okay. Okay. Okay, Bete.
Thank
Thank
you
you
so
so very
much.
much. Take care, Bete.
You
Allah
too.
Hafiz.
Allah
Thank
Hafiz.
you. Thank you.
يا ذو الجلال والإكرام يا حنان يا منان يا فاطر السماوات والأرض يا أرحم الراحمين يا أرحم الراحمين يا سميع الدعاء يا سميع الدعاء दुआओं को सुनने वाले रब हम आपके गुनाहगार बंदे आपके आगे हाथ फैलाए रहे हैं या अल्लाह हमारे सगीरा कबीरा गुनाहगार हैं जानी गुनाह खुफिया एलानिया गुनाह बचपन से लेके आज तक जितने गुनाह किए हैं, जिनको गुनाह ना समझते हुए भी गुनाह थे अल्लाह पाक उन सबको माफ फरमा दीजिए हमारे से पहले से पहले तमाम गुनाहों को माफ फरमा के आप हमसे राजी हो जाइए या अल्लाह कब्र के अजाब से कब्र की तंगी से कब्र की वहशत से कब्र के कीड़े मकोड़ों से हमें
Hello, Mahia. How are you? Hello, Mahia. Can you hear me?
Can hear you. Oh, hi, Miss Shubnam. Can you hear me?
Yeah, I can hear
Oh,
you now.
I think I was on mute. I'm sorry.
That's okay, no problem.
How have you been?
I'm fine. I'm good.
How's your health? You were unwell for a
Oh,
while.
thank you so very much for asking. Yeah, I'm all fine, Alhamdulillah.
Yeah.
Actually, I'm asthmatic, so that's why sometimes,
Oh, I see.
yeah, sometimes it's really very difficult for me to cope. And nowadays we are going to have that winter season. So in winter
Yeah.
it triggers actually.
Oh, oh, take care of yourself, Miss Shubnam.
Thank you so much, Maya. Thank you. All right, how are you doing?
I'm okay. I my chemistry test got moved from yesterday to Monday.
Oh, so lucky you got
So,
two
yeah,
few more days. Yeah.
yeah.
Okay.
So
So
now yeah.
yeah.
Sorry. No, no,
Sorry.
no.
Yes.
I just wanted to focus on some organic chemistry.
Mm-hmm. Okay.
And
I have sent you some question. Have you seen them?
yes, I have it in front of me.
All right, fine. So should we do them?
Yeah,
I tried to put in all the questions which are related to different classes.
yeah.
Okay. So I'm going to share my screen.